All right. Hey, everybody. I'm Olivia Radcliffe, and I am here with Dr. Gustavo Varca. Gustavo, I'll let you go ahead and introduce yourself a little bit here.
Hello, everyone. Good morning, good afternoon, depends on where you are. I'm Dr. Varca, also known as Dr. V, and I'm going to be speaking with you guys a little bit about radiation technologies. And today, I think we have a couple of questions again that people send to us, and I'd be more than happy to answer them. So,
yeah, we've had some questions lately about some just EBeam processing of products that require special handling and special storage, things that might not be compatible with other sterilization processes or be really hard to process. And so trying to figure out how EBeam actually can help those products, what the processing actually looks like. So I think if we just go through, Gustavo, and just maybe give some examples and talk about some different specialty products that we've seen that EBeam technology is a good fit for, in general. If you have your favorites you like to talk about.
okay, I'll try to summarize that because that was a
Yes.
long question. So, when we talk about radiation technologies, we're talking about means or tools to sterilize the product or get the product processed, right? It's either for cross-linking or for sterilization or for simultaneous process. We're really talking about, getting the results the customer is expecting, but on the other aspect, there are logistical aspects. There are lots of aspects that need to be taken into consideration. EBeam, electron beam technology is kind of interesting because it allows people to deliver the dose very fast if compared to other technologies. So this gives service providers that have EBeam an ability to have a good turn and a fast turnaround. On the other hand, electrons have mass, so they have limited penetration. So you can't do a bulk package. So depending on what we are talking about, it's actually helpful that this phenomena happens, because if we're talking about maintaining a specific temperature range within a container, it's a lot different than maintaining a specific temperature range in a single unit or in a small case. So the fact that we can deliver the dose very fast also allows us to reduce the timing between, taking them, out of the package from the freezers, putting them in a belt or in whatever configuration they're going to be run at, process them and put them back. This processing window becomes shorter. So it allows EBeam, electron beam technology allows a faster processing, which at the end allows a better temperature control. We are also able to process it at a controlled temperature. We can process it at cryogenic temperatures, which is below water freezing point. We can also do it at refrigerated conditions, or we can even heat them in some cases where we want to deplete oxygen in solutions, for instance. So the ability to deliver a fast dose and have a precise control of it, and also the ability to have consistency in delivering the dose in units as opposed to bulk scenarios actually can be very helpful for 3D printed objects, for instance. Parts that are based and manufactured not in bulk, they're manufactured individually for specific purposes. They can be a great fit for electron beam because of the faster qualification stages, the faster delivery, a precise delivery of dose, and of course a better temperature control.
So what are some examples? What are some examples of products like that?
Catheters, right? Custom designed bone parts for bone replacement. They have an interesting density, but they also are customized. You can't put them in a box. If you're talking about a patient that is, a teenager, a patient that is an adult, they will have different bone sizes. So you can't group them. You have to process them individually. Some metal parts, when we're titanium alloys and some of those alloys that are used in biomedical or for biomedical applications, they can be pretty tricky, and the ability to process them individually may actually bring lots of benefits as opposed to a bulk scenario. So, specific requirements may lead to specific types of processing that can be achieved using electron beam technology.
Right. And so EBeam can kind of handle really small lot sizes of things, right? Very customized runs, as well as larger sizes. But right now you're talking more about just individual boxes coming in. What?
Yeah, ultimately, yes, that's exactly what I'm talking about. People in this business are always looking for alternatives for truckload volumes and huge volumes. But what we're talking about is a specific niche, a specific demand for things that can change people's lives. But at the same time, they're small, but important enough to be considered. And electron beam technology can offer a lot towards those needs and applications, right? So I wanted to highlight that also because we were at the MD&M show recently, and we were approached by multiple companies that were actually building customized parts for multiple applications. And it's hard for them to understand how to qualify that. First, people don't even want to talk to them because you're never going to have a truck of the same parts. They're customized. They will show up 2, 3, 4 parts. Each one of them will need to have specific dose settings, specific dose parameters. And I feel like EBeam technology is a message that needs to be spread in that niche as well.
So if someone has this sort of customized product that they need to have sterilized, what do you recommend as their first steps getting started? How do they go about finding someone? What questions should they be asking? What should they be looking for?
Well, I guess the first step is understanding if what are the material requirements, if the material would tolerate, what type of sterilization would the material tolerate, right? Would it be, could you use a chemical process? Do you need to use a physical process? And do you have it available? And if you don't, then you got to find a solution for that. Ideally, they should consider that in the design phase, but that's really rare to happen, I would say. But they should find a good service provider and start working on identifying a compatibility, which we know as compatibility tests, material exposure tests. Basically, we would expose parts to different doses and try to understand if the material would tolerate that type of processing, and if so, how many cycles in case you need to reprocess it at a given point, right?
So essentially, their first step should be to contact EBeam Services.
Well,
right?
Exactly.
So once they establish compatibility, what's the next step from there? Once they know their product is good with, let's just say EBeam, because we're talking about EBeam.
They need to identify what their dose is, right? They need to do some bioburden testing and identify what dose needs to be delivered. And ideally some sort of a initial dose mapping or dose study to understand the dose distribution for a model type, right? You won't have to do a dose map for all the units, but we have some tools to define some ranges that we can deliver the dose and keep them consistent. So once you go through that phase, then it can become production and routine, right? So it's a special type of dose map that would allow people to bring, keep, as long as it keeps the same footprint, but we would be able to tolerate different dimensions, with some good range.
Yeah.
Right?
Yeah.
I guess so.
Okay, cool. Well, thank you so much. I think that's a good start to that conversation. Maybe we'll go more in depth here in a little bit. Maybe we'll jump on again next week or something.
All right.
But all right, if anyone has any questions, post a comment below, reach out to us, ebeam@ebeamservices.com, and we can, Gustavo, myself, we can all walk through your product and recommend the next best steps for you. All right. Take care. See you.